All right, you guys have a big quiz tomorrow. Uh, I got the question, how many problems will be there? My goal is 8. Okay. So I'm not saying that as a promise. I'm just saying that I think I can trim some fat. I feel like there's some repetition on the practice quiz that I can do away with. So I'll write the quizzes either tonight or today when I get some free time. Either way, but that's the goal, is to trim some of that off. So I trust you've had a chance to grade your answers. So let's go through this though, just so you have an opportunity to ask some questions. So, and feel free to ask questions as we go, because why not, right? I've got about 4 minutes per problem. That's not entirely true. It's closer to probably 3.5, but we got this. What's the clue in problem one? What's the, say again? Yeah, the 63 is a big clue. It tells us to think about 8 times 8. So I know, since I'm trying to make an 8 and an 8, if I'm clever about this, I can put my first 8 here and my second 8 here, forcing them to multiply to make 64, because that's close to 63. So I'm going to put x to the third, and then, of course, just regular x to the third. And I still have a decision to make, and I want to put the plus here because I want the big 64 to be positive to make the positive 63. And then I'll put a 1 here and stick the weak minus here. So when I grade these, now that we're into multi-step factoring, problems are going to be worth different amounts. So like generally the way I'm going to grade is going one level is a 3-point process. So if you make it here, nice. But some problems will be worth 9 points. I've even done some that are worth 12 points where you can just keep going and going and going. So just bear that in mind. So if you got this far, good job. What are these things?
Different central views.
Right, they're all cubes, right? And with cubes, we don't care if there's pluses or minuses. We can go both ways. So we have a lot of work left to do. So for this particular difference of cubes, my A value is 2x and my B value is 1. And then for this sum of cubes, my A value is just x and my B value is 2. So you all should have done a short set, long set, short set, long set. And this we know will have to be the final answer because, again, long sets are not factorable, provided that, as you'll see, starting like next week, if there was a GCF at the beginning of the problem, we would have already presumably gotten it out. So that would be the only exception to saying that the long set is always dead. That'll make more sense like next Tuesday or so. So anyways, plug it all in and you get A minus B times A squared plus AB plus B squared. And then your other one is going to be A plus B times A squared minus AB plus B squared. Any questions about that? Okay. And again, these entire worked out answer key has been on Canvas for like, I don't know, 16, 18 hours or something. So you're welcome to obviously go back and take a peek. Problem two is 6x to the fourth minus 13x to the tooth minus 63. So this one requires a little bit of experimentation. I'm not going to sit here and go through the experimentation process with you. Time's a ticking. So I am going to just put these, and then I know I need a 9 and a 7. If you put the 9 across here, you build a 27. And if you put the 7 here, you build a 14. And 27 and 14 make 13, provided, of course, that one of them's negative, which it will be. So, and then we have a choice to make. Who do we want to be stronger? We want the bigger, the negative to be stronger. So we're going to put the 27 as our negative by putting the minus there, and then make the 14 weaker with putting a positive there. Right. So that would be 3 points if you get this far. What do we do after this?
We take that difference of cube, difference of squares.
Right. This is not a difference of squares. So the reason we practice this stuff so much is so that we can work out those misconceptions, like what Homeboy just said. Two ruins it, right? There's a lot about this. Like again, I'm not throwing these out arbitrarily. I sit with a note card and I work really hard to construct problems from the ground up. And I put this right here to make you want to factor it. Don't let me win that. Don't do it. Don't fall for it. The two says, I ruined it. I'm out. This is the final answer. There's nothing we can do. Okay. With squares, we are looking for minuses only. So the first one obviously was dead. And then we're looking for perfectly square rootable items. But the 9 is good, but the 2 is bad. So that one is done. So that would just be a little weak 3-point problem. Any questions there? Okay, number 3. X to the 8th minus 5x to the 4th plus 4. So we know this one should be a little bit easier for us. We know there's only one way to divvy this up like this. We know that both signs are minuses. And you do enough of this and you realize that you're looking for 4 plus 1 to make 5. So where we put them is irrelevant, but just like this would be just fine. So the thinking here is that we got our -1 on the outside and our -4 on the inside to make a -5. What are these? Both are differences of squares. You do not have to have a power of 2 to be a square. You have to have any exponent that's a multiple of 2, an even number. So this green one is going to factor down into x squared plus 2 times x squared minus 2. By definition, that is how you factor down a difference of squares. This red one is going to factor down into x squared plus 1 times x squared minus 1. I see 4 candidates now for continuation. Do any of them factor further? One of them does. The ones that I would hope that, first off, the most obvious one that if you fell for it, oh boy, oof, this one is just utterly garbage, right? The plus sign out, the 2, like don't even go there. That's garbage trash. So I can copy it down right now. Say, yeah, you're done. You're dead weight. What about x squared minus 2? 2 is not a square, which means that this one is also dead, which means we can copy it down. X squared plus 1, looking pretty good, huh? The plus ruins the squares. Squares cannot be factored with plus, not using real numbers. So this is out. We get x squared plus 1. And what about the last little fellow?
Yes.
I like him. He is a classic difference of squares. So last guy is our only factorable guy. He's going to factor into x plus 1, x minus 1, like that. Good. So that would be a final answer for number 3. So we would get 3 points for doing this step. We would get 3 points for doing this step, and we would get 3 additional points for that last step. So some points, some problems are worth more than others. Good, good. Any questions so far? Number 4. X, 4, oh no, 4x to the 4th minus 7x to the 2th plus 3. So again, you would go through the process of trying maybe 2x squared and 2x squared, but in the interest of time, we'll just cut right to it like this. Okay, and it might have taken a minute to find that. That's okay. But eventually, what helps here is you do know that the signs are both minus. And again, your spidey sense, the more of these problems you do, you become wise to little things like how 4 plus 3 equals 7, right? You just start to see stuff like that. And so if you don't want to put the 3 across from the 4, because then you make a 12 and you blew it all up. So by putting the 3 here and the 1 here, that's how you can actually build a 3 plus 4 scenario, keeping them both with the 1s. So that would be 3 points. Any questions on that? Is it dead or carry on? Which one? What's wrong with this one? The three. The 4x squared is like, I did my job, and the minus is like, I did my job, and the three is like, sorry, dudes, I'm out, I'm trash. So we're going to copy 4x squared minus 3. That cannot go any further. Just because it's got like a square and a minus, and it doesn't mean it's passable. And then, of course, you just saw this one a minute ago. That one's just x plus 1, x minus 1. Right. So that would be a 3 point, 3 point, 6 point. Questions? Okay, number 5. So we know it's going to be a 4 and a 1 just to create the dynamic that we're looking for with the 3. So it doesn't really matter at this point where you put them, just put them like this. Just make sure you give proper sign respect to the one that you want. In this case, you want minus to be the end result. So you want to give the minus to the strong 4 and give the plus to the weak 1. What is this guy, the yellow guy? Dead. 4 ruins it. He tried to be a difference of cubes, and then 4 came in and said, sorry, my bad. What about little green fellow? What's he? He's a sum of cubes, where A is equal to X and B is equal to 1. So you're going to actually construct now a short set and a long set to finish the problem. What's my short set going to be?
X plus x squared minus x plus 1.
That's it. You should never like wonder if you're done. Like you'll know when you're done because you should be filtering trash to the left. So all you ever have to check are the new guys. And we already know the new guys are both dead. So we're done. That's it. Problem 5 in the books. 6 is x to the 4th minus 16. What is that?
Finally.
I agree. What else is it? That's what it is. And again, I have to keep stressing this. Just because your exponent is not a 2 doesn't mean you're not a difference of squares, right? Your x to the 4th is a perfectly fine square. So when we factor this guy down, we're going to factor it into x squared plus x squared minus square root of 16, square root of 16. Anybody factorable? The plus 4 is dead, right? So we'll filter that one out to the left. Cannot do squares with pluses. I would put that in my notes if I were you. In fact, I would write it in a special color and I would make it take up a good portion of a corner of a page. If I had $1 for every time someone tried to factor this down, I could probably make at least one mortgage payment. Don't do it. Squares don't work with addition. Don't fall for it. Just because you see some stuff you like, it's got to pass all 3 tests. Square, square, minus. All 3 must pass. This one is, of course, a difference of squares. He fits the mold, so he's x plus 2, x minus 2. Rocking it? All right, that marks the halfway point. Do you have any questions so far? Okay. Number 7. And remember for your notes that squares have to have plus or minus. Cubes, you don't care, right? Cubes go both ways. Squares, you got to be picky. All right, x to the 6th plus 8x to the 3 menos 9. It's always a nice little break when there's no number in front. Like, it just feels relaxing. So the signs are going to be positive, negative. And again, you don't want to even think of 3 and 3 because 3 and 3 would cancel out with the plus and the minus. So obviously we want a 9 and a 1. because 9 and 1 make 8 if one of them's negative, right? And you're pretty good at this. You understand that because we want a plus in the middle, we want to give respect to the more powerful. Put the plus on the 9, put the minus on the weak 1. Anybody factorable? What's wrong with x cubed plus 9? Yeah, 9's a square, not a cube. Again, that doesn't happen by accident. When I'm writing these problems, bless you, I'm totally focused on trying to lay traps. And to earn a good score on this quiz, you're going to show me you're an expert trap dodger. You're not going to fall for this nonsense. It looks like a sum of cubes, and it wants to be a sum of cubes. And 9, though, even though 9's divisible by 3, is not a cube. So x cubed plus 9 is dead weight. But x cubed minus 1 is a pretty classic, simple difference of cubes. What's A? What's B? So you're going to go short set, long set. What is shorty going to be? Long set. Like that. Questions there? Great. I think we might have gone over this problem yesterday, but it might have been fifth hour. I don't know. Doesn't matter. We'll go over it again because I'm recording and going to be thorough. So, what is that? It's a difference of cubes, and each of them is a cube in his own right. I understand that the number 9 is not a cube, but when you're an exponent, it's not about whether or not you're cube rootable. It's a matter of are you divisible by 3? And it is. Therefore, by definition, he says, I'm a cube. And 512 is a cube in his own right because it's on our list and we know the cube root of 512 is 8. So our A value is x to the 9 divided by 3. Divide your exponents by whatever kind of root you're taking. Square root divide by 2. Cube root divide by 3. And the cube root of 512 is 8. And it's go time. Short set. Long set. What goes in is a short set? A minus E. Never changes. It never will. That's what's nice about formulas. Repetitive, predictable, reliable. And this is a tough spot. I will say that over the years, we're about to go to one place where I've spent probably proportionally more red ink than any other place. So if you have a question about this part, ask. What goes right here? It is x to the 6th. And when you're, tinkering around with roots and powers and stuff, you're playing with exponents, but not in an additive sense. You're doubling the exponent when you want to square it. Okay. So you put x to the 3rd, but you take the 3 times 2 is 6. That's what goes there. I've seen a lot of people put 5s there over the years. The sign is going to be a plus. And then the next one, remember, is just the classic mashup, a times b. So that's just 8 x cubed and then plus 8 squared, which is 64. Done? No. Again, don't fall for that nonsense, right? What do you see? This little guy's like, don't forget about me. I'm my own little difference of cubes. And so we have a little, bless you, we have a little more work to do. What is A value on this QB? A is X. What's B? 2. So what I like to do, and I don't know that I didn't do it on my answer key, but I was just rocking. I wasn't really paying attention. Just to kind of be consistent with you and how I instruct you, I would personally pick up what I have underlined in white and transport it over to the left. It doesn't matter if you do in a case like this, but I'm just going to move it, oops, so I can be consistent. And then I'm going to break down my yellow egg into shorty long like this. What's shorty? A minus B. You got it. Long set. A squared plus AB plus B squared. Done. Got short set trapped between two long sets. It looks pretty cool that way. I like it better. You doing okay? Okay. That was number 8. Any questions on that? What's 8 divided by 12? Reduce that. What's 8/12 if you reduce the fraction? 2/3? 66.6 repeating percent of the way done. What percentage will we be done after problem 9? 9 out of 12 is 75%. Nice. Look at us. We're mathing. I had a lot of questions about this. I would tell you that with numbers like this, you should always think of something. Listen, you're not going to remember a lot of what I teach you this year. I'm fine with that. It doesn't keep me up at night. It's realistic. But when you go out into the world and just your ability to work with numbers is useful, I think. Um, Always think of quarters. Whenever you see a number that ends in 0025, 50, or 75, you should always ask yourself, could I make that with a pocket full of quarters? And the answer will always be yes, right? It helps. A lot of times math facts are hidden because we don't teach you times tables up through your 25s, right? But how many quarters would you have in your pocket if you had a $1.50? 6 quarters in your pocket would equal a $1.50. So we could be thinking here, just the simple thing is to just immediately think of 6 quarters, right? 6 quarters make a $1.50. So just a useful tidbit for you. So the question becomes, well, why is that useful to me? Well, 24 and 25 make 1, right? Provided again that one of them is negative, and I'm trying to make a -1 in the center. So if we're creative, maybe that's not the right word. If we're clever about this, we can put a 4 here and a 6 here to make 24. And then we can put a 25 here and a 1 here to create that 24-25 dynamic. So um, just something to think about. Put the minus on the 25, put the plus on the 6, and there you get your proper -1, -25 plus 24. Either of these factorable? Both? Just the first one? You don't like the second one? Yeah, you should not even be considering these anymore. I mean, I'm going to keep asking my stupid questions, but you shouldn't even be remotely tempted by the second one. It is so trash. So we're going to take x² + 6 and bring it down to the front. Just say, yeah, you can sit there and just chill for a minute. What is red guy? Like, what is it? What's his name? It's not a difference of cubes. It is a difference of squares, right? And I'm assuming that's what you meant, but with the difference of squares, there's no short set, long set. Squares are symmetric, right? It's two short sets. And so to do squares, you take the square root of each entity. What's the square root of that? The purple egg, not this one. What's the square root of this purple egg? 2x. Bless you. What's the square root of this yellow egg? Right? And if you can answer those questions, you can factor any difference of squares in the world. So you just build 2 sets and stick your square roots in there. So square root goes here, square root goes here, square root goes here, square root goes here. Give one of them a plus, one of them a minus, and you're done. Squares should be nice and simple. Any questions yet? 75% of the way done. Number 9, number 10. What is this? What is it?
Quarter.
Yes, you were toying with my emotions. Right? It's hard to go back and forth between how to treat exponents and how to treat regular numbers. I get that. And that's hard. So remember with exponents, You're looking for divisibility with regular numbers. You're looking for root ability. Completely different concepts, right? So because 8 is even, then this red egg is what we call a square. And then 81 is, of course, a square. So the square roots of these items are x to the half of 8 and square root of 81, which is 9. That's how you do a difference of squares, and then you just build them. So you go square root here, square root here. One gets plus, one gets minus. Anybody factorable? Second one, what's wrong with the first one? It's a plus. Squares cannot have the plus. I mean, they can, but they're not going to be factorable. So first one is already right where it should be in the trash bin. What is this fella here? I'm going to keep asking. It's a difference of squares. My version of professional utopia is when all voices just beautifully, like in the symphony of awesomeness, can just say difference of squares at the same time. Like that's my work life utopia. It's going to get, 40 kids at the same time to do that. And that is a difference of squares. So the square root of x to the fourth is x squared. The square root of 9 is 3. And that's a minus. So we're green lighted to proceed. Square root plus square root minus square root. Who's factorable now? None. I agree. All right, we already knew the first guy was trash because of the plus. Middle guy's trash for 2 reasons, because of the plus and the 3. Last guy's trash because of the 3. So that is it. Final answer. Number 11. X to the 6th minus 26 x to the 3rd. Again, do you see the hint here? Like this isn't, I'm not trying to hide anything from you here. Do you see that dynamic between the 27 and the 26? The 27 is like, let me help you here, Holmes. Like, just give me a chance. And so I know to take x to the 3rd, x to the 3rd, and I want to use a 27 and a 1 to create the dynamic that I will make the 26. All you got to do now is be smart and ask yourself, what do you want the outcome to be? Well, according to that little red circle, we want the outcome to be negative. So we're going to give all of our mass to the one that will be negative. So bam, put the minus on the 27 to force it, and then put the 1 on the weak little one to force that. Anybody factorable?
They won't time.
Both IDs?
Mhm.
I've never said that during a lesson before. It's awesome. Yeah, that was so rad. I don't care what else happens for the rest of the day. I just said both IDs during a lesson. It's all downhill from here, right? This is a difference of cubes. What's A? What's B? And then our second guy, what's A? What's B? Yeah, it's it. We're done. Short set, long set, short set, long set. And you would remember like there was like this is basically the same as problem 1. So when I'm looking to trim some fat tonight, when I'm knocking the 12 questions down to 8, I probably won't. This might be a good place to trim some fat. Like been there, done that, right? So our little green set is going to be A minus B times A squared plus AB plus B squared. And our little yellow set's going to be A plus B times A squared minus AB plus B squared, like that. What did you say? Holy buckets. That's what Mr. Manlove used to say all the time. And he got me saying it too. Holy buckets. Let's do it. Let's catch it on, and then I'll report back to my good friend, Mr. Manlove, that all the kids are now saying holy buckets.
Man. What a guy.
Just saying. He'd be honored. He's been sending me a joke of the day every day for about the last week. Do you mind if I I'll just keep recording. I'm going to see if I can find yes. Do you guys mind? Hold on a second. He sent me one yesterday. Oh, here it is. He said, "Hey, dude, do you know where I can get some camo pants? I can't seem to find mine anywhere." Nothing? You can laugh later when I'm not looking. It's okay. Yeah, so this is the one that we talked about yesterday about you're going to be faced with a choice. Listen, the beginnings of these problems, I'm not going to give you choices. Well, I might have to recant that statement, but the beginnings are pretty predictably just look-alikey, right? So you're just going to break it down into x to the sixth and x to the sixth, and we know we need a 1 and an 8 to make the 9 because they're both minuses. So yeah, well, easy peasy. So I'm going to start with this, the one I'm underlining in red. What is that?
Just like this.
It is just a difference of cubes, right? So I want to get this one out of the way first, just so we can have a good talk about this, the other one. Probably should have written these in another order, but let's focus on red first. For red guy, he is only cubes. X to the sixth is a square. That's a minus. It's in the running, but then the 8 ruins it for square eligibility. So cubes it is, where a is x to the power of 2. Remember, you have to divide your exponent by 3 when cube rooting. And then the cube root of 8 is 2. So let's knock this one out first. So we'll just transfer over to the left. We're going to have a minus b times a squared plus ab plus b squared. So red is dead. Oh, no, it's not. Why did I write? Hold on a second. There's nothing to see here. You can't, well, I was going to say you can't prove it, but I'm recording. So, um, rats. Um, anything factorable on the left?
Yeah.
The red. I'm sorry, I'm trying to use colors. Is anything in the red that I just wrote still factorable? First one? No, the 2 ruins it. So first one we can just rest assured is dead. The conversation I wanted to have with you is the gold box. And I wrote this on the board yesterday. And what is it? What is the gold box?
It's a square.
And
And the difference of key.
good. I will go out of my way at some point to make sure that your version and Fifth Hour's version and the retake version and the I was gone for a week version, like every one of them will have a situation where you have to choose. Got it? What will we choose?
It's a square.
Squares. You're going to get more meat off the bone if you pick squares. You can still do it with cubes, but the process of factoring the long set is really kind of complex and nasty. So if we do squares, everything pops out in the open. It's super like user friendly. So write that also in your notes when you're making a page of notes that when faced with it, it could be this or this. Pick the squares. Got it? So we're not doing short set, long set for the yellow box. We're going to do symmetric classic difference of 2 squares. What's the square root of the green egg? Square root. It is. Divide the exponent by 2 when tooth rooting. Whatever kind of root you're taking, you divide your exponents by that much. A second root, a square root, a tooth root, whatever, call it whatever you want, means divide by 2. So we're putting x to the third here and here. And then, of course, this question is pretty straightforward. What's the square root of 1? 1. So you put that here. And then to complete the process of difference of squaring, you give 1 of each. What do you see now? What are those little colorful fellows over on the right? Difference and sum of cubes. We got 1 of each. We got the full sampler platter here. Problem 12 is going strong. So for the first little set, that's this white one. A is X and B is 1. And for my second little set, I'll just same thing, right? A is X and B is 1. So our final answer is going to be early trash x squared minus 2 times early trash x to the fourth plus 2x squared plus 4 times short, long, short, long. Kind of a menace, huh? So what is our first little shorty long combo going to be? X plus 1 and booth minus 1x plus 1. Good. Second shorty. Times plus 1x plus 1. And again, this is possible if you go the cubes route, but don't do it. Don't do it. No es bueno. Okay. Do you have any questions for me? You may use the remainder of your time to ask questions, of course. You may work on that page of notes that you're, of course, going to have. You may be productive, do anything that's going to help you to score your best possible score 23 hours and 20 minutes from now. Let me know if I can be of assistance.